Now let us revisit the process of finding an area under a given curve with the help of definite integrals. So as we had seen in the beginning, the geometrical meaning of definite integral is nothing but it gives the area under a specific curve between the two given limits of the variable. So here for an example, let us see that there is one curve given here of some function, say y is equal to f of x. The curve is shown in yellow color. Now we have to find the area which comes beneath that curve but above x-axis and bounded by two limits a and b. So x varies between a to b only. So we can see that it forms a kind of closed figure, and we have to find what is the area of this particular region. Alright. Now to do that with the help of definite integrals, we consider a vertical strip of very small width. So technically that is called as infinitesimal width, right? And we call that width as say dx, right? Now since this width is dx, the two vertical heights that you are seeing of the width are practically the same. They won't be having different lengths, so we have to consider both of them as the same. So that means if you look at that particular strip, then it is nothing but a rectangle of length as y and breadth as dx. So therefore its area, the small area, will be denoted by dA, which is nothing but length into breadth, which is y into dx, isn't it? So this is the area of one small vertical strip. Now to cover the entire region, we must consider all the strips that are present in the particular region, and there will be infinitely many such strips because the width of each strip is infinitesimally small. It's not a finite width, right? So therefore, since there are infinitely many strips, we cannot simply add them in a discrete way. So that means we cannot use the summation process, but here we have to use the integration process because it's a continuous addition. So therefore the area is given by integration of the small areas, right? And the integration is to be done between the limits a and b, isn't it? Because we want to find out the area only between these limits. So therefore which turns out to be integral from a to b, and dA is nothing but y dx. So that means since y is given to us in the form of the definition of the function, that is, we know how to express y in terms of x. So once we put y as f of x, we can calculate the integral of f of x using all the known methods that we have seen, and we have to integrate that between the limits a to b. So finally we will have to evaluate using the limits a and b, right? So that is the way to find out the area that comes between a curve and the x-axis, right? Now let us see an important fact regarding the value of this particular area. So on the next slide it is given as a note, that is, if a curve is above x-axis, then the area under that curve is positive. So numerically we will get that particular area as a positive number. But if a curve is below x-axis, then the area under that curve will turn out to be a negative number. So therefore we have to take its absolute value, simply because area cannot be a negative number. So in general what it means is, suppose we have a general curve, something like this, right? And we want to calculate the area between two limits, say this is a and this is b. So in this case we will see that there is one portion which lies above x-axis, so therefore its area will turn out to be positive, whereas for the other region the area will come as negative number when we find out the definite integral. So for this particular second region we have to take the absolute value, that is, just remove the minus sign and then together add up both the areas. That will give us the total required area from a to b. See, if we don't do this, then what happens is the positive and negative areas will have a net effect, and the total area will be less than the required area. So if you want one more example, if we consider say a sine curve, okay, so we know that the sine wave looks like this. Suppose we want to integrate it from 0 to 2 pi, that is we want to find the area below the sine curve from the limits 0 to 2 pi. Now we will see that whichever is the area that lies above x-axis will be positive, and exactly same area lies below the x-axis, which is negative. So if we just straight away integrate from 0 to 2 pi, we will get the answer as 0, simply because positive and negative areas will cancel each other. So therefore, to avoid that, we take the positive area as it is, and for negative area we consider the absolute value, that is modulus. Now moving further, let us consider another possibility where we have to find the area with respect to y-axis rather than x-axis that we just saw. So suppose we want to find out the area which comes between the curve and the y-axis and between the two limits a and b on the variable y. Alright. So we are interested to find out what is this particular area shaded in green. Alright. Now to do that, we follow a very similar process, but the only difference is that instead of considering the vertical strip, we now here consider a very thin horizontal strip. Alright. Now in this case, the width of the strip will be dy because it's on y-axis, and the length of that strip will be nothing but x. So therefore, the area of this small width, small strip will be nothing but x into dy, and now total area is therefore given by integrating all the areas of these infinitely many thin strips between the limits a to b. Remember, these limits are on the variable y. Okay. So putting in the expression for dA, we have x dy, right? And we will be given the function y equal to f of x. If that is the case, then we will have to convert it so that we can express x in terms of y, because in the integral we want to substitute x in terms of y, and that can be given by this particular example, right? So if we see conceptually, it is the same process, it's just that the variables are different depending on whether we want to find the area between the curve and x-axis or between the curve and y-axis. So looking at the question, we will have to decide which approach we should follow. Okay, any area can be calculated using vertical as well as horizontal strip, but one of the approach would be easier and simpler than the other. Now based on this, let us solve few examples of finding out the areas.